Question 4. Exercise 2A, the textbook. So, two capacitors of capacitance 4 microfarad and 2 microfarad respectively are joined in series with a battery of EMF 100 volts. The connections are broken and the like terminals of the capacitors are joined. Find the final charge on each capacitor. Copy the question out, then follow me. Let's go and look at it. So first of all, let's connect capacitors in series. I've already taught you all these things, so I won't be going deep into trying to explain so many things. But you just need to know that if this is series, they say they give us 4 microfarad and they give us 2 microfarad, then they give us 100 volts. This is how to be in series. So first of all, find the capacitance in series, and this is something as saying 1 over C. 1 over total capacitance is equals to 1 over C1 plus 1 over C2. So in that case, you will now have 1 over C will be equals to 1 over 4 plus 1 over 2. Which if you take the LCM, this is 4. 4 into this is 1 plus 2 into this is 4 is 2. So 2 plus 1. 2 times 4 divided by 2 is 2. 2 times 1, 2. Yes. So that I have 1 over C is equals to this. So 1 over C is equals to 3 over 4. This is the sentence in 3C cross multiply equals to 4 times 1, 4. So divide both sides by 3. You have C is equals to 4 over 3 microfarad as the capacitance. Now, if you've gotten this, that means that charge, you know that charge in capacitors in series is always the same. The charge in a capacitor in series is always the same. So that means that you now have Q equals to CV. And that means that you have Q to be equals to 4 over 3 times the 100 voltage given, which is going to be Q equals to 400 over 3, which is equals to 133.33 microcoulombs. So that is the case. So and you need to know that Q1, the charge in this place is the same thing with the charge here. So Q1 is equals to Q2, which is equals to 133.33 microcoulomb. We don't have problem. Even assuming they ask us what is the voltage, because we know that voltage in series they are different. If they ask us what is the voltage in this and what is the voltage in this, we can simply say since Q is equals to since the charges are the same 133, we can just say from Q equals to CV, we have C1 now and V1, which will be now Q will be equals to 133.33 equals to, that is 4 and V1, which is going to be giving me V1 equals to 133.33 over 4. V1 equals to 33.33 volts. And then for this Q equals to C2V2 to be 133.33 equals to 2V2. So if you divide by 2, you have V2 equals to 66.67 volts. Now you need to note for voltage in each capacitor in series. So the voltage for each capacitor in series, this is the voltage running across it, because you might be confused and start doing this. It's different from that part where they asked us, where they tell us that the voltage is broken. Like this thing now, this charge is broken. Sorry, this voltage, that is work flowing, is broken, and they tell us that like terminals are connected. So if like terminals are connected, no charge is flowing, because positive and positive does not attract. So what happens in that case is that charge will just be redistributed. I'm trying to rush it. I want it to just be 6 minutes. So in that case, it simply means that charge there will be the same. Capacitors there will be the same. But we know that if this is, let's see this, if this is what we have and the voltage EMF is broken, it simply means that this is the case 2. So this is now the case 2, where I have 4 microfarad and I now have 2 microfarad. So if you look at this, you see that positive, positive, negative, negative. That is what they are trying to talk about. Or you can see this thing as the same thing as saying a case where I now have just this, which is that 4/3 microfarad. And no charge is flowing. So this is that case. So you need to know this. So, but since they say that it is broken, this is the idea I want us to use. So for that reason, I can say in parallel, Q1 will be equals to C1 V final. The voltages will always be the same. And Q2 will be equals to C2 V final. So you remember, these two are Q1, they charge on one particular part. The Q1, that is, if the light terminals are connected, so we have 133.33, we have 133.33. Sum it up, you have 266.66 will be equals to, sum these two up, you now have 4, sum these two up, that is the first charge and the second charge, they are connected in positive terminals because that's where charge flow from. So we now have, so adding this, we now have 4 plus 2. So 4 plus 2, then VF and VF is the same thing, so VF, so you now have 6 VF is equals to 266.66. So divide both sides by 6, so that you have V final is, V final, or you just say V. So the voltage that you find when you've disconnected this, that's what I mean. So you now have it to be 44.44 V. So that is the voltage. And you remember, you need to remember that if we are talking about parallel, voltage in capacitors, for capacitors in parallel will be the same, but the charges are different. That is why when I treated that of series, I tried to elaborate on this. So let's do the same case there, and that is the question they asked us, the charge on each. So we simply do Q1 will be equals to CV for something in parallel, so that this becomes 133.33 is equals to yes, okay, sorry, the charge is what we are looking for, not the charge in series, for parallel, sorry, for parallel. So we now have Q1 is equals to C1 and V final. C1 is 4, then V final is 44.44. So by the time you do it, Q1 will give you 177.78 microcoulombs. If you want, you can convert your own to coulombs by doing this now to be times 10 raised to the power minus 6. So then Q2 will be equals to C2VF, so that Q2 will be equals to 2 times final voltage, that is, remember that voltage for parallel is always the same, so Q2 will be equals to 88.89 microcoulombs. So if I know this, it simply means that the answer, or you say that is answer, charges on each capacitor in parallel Once you hear that voltage is removed, after voltage, or you say, or battery, after EMF is broken, it means that battery is removed. After battery is removed, so once you remove battery, always think of it that what is there now is your capacitors are going to be in parallel. Is removed, is now 177.8, that's approximately 177.8, and 88.9 microcoulomb. All right, so there you have it. If you don't understand, go back and watch the first videos on this course. This is not where it started. We started from introducing the course properly. Thank you. Subscribe.